Morning, guys. Morning, Jake. Morning, Ryan. Morning, Azra. Morning, Hike. How you doing, Ava? Hi, Downey. Hi, Charlie. Hi, Eric. Hi, Kimmeline. So, today, shorter on the agenda, but number 2 is going to take a while. First thing is our DNA question. Compare and contrast an asteroid to a comet. So, taking our answers on Tuesday, taking our answers from Wednesday, and putting them together to look for a similarity and a difference between those two objects. You can look back to those images from yesterday on a comet, and then images back on Tuesday for an asteroid. One similarity, one difference. And then that would complete your sheet once we go over it. Add in any missing information. Hi, Hayden. Had to refresh Classroom because Tour of the Solar System was due midnight or due beginning of today. I did grade a bunch that came in yesterday. Didn't get very far into period D, but if you did them in other classes, I looked at them. Overall, so far, they're coming out pretty good. You can't see your grade yet because I haven't returned them, but I mean, if you saw my comment, you could probably kind of figure out what you got. So they're coming out really well, and you're going to see 8 or I don't know, maybe 9 today as we go in number 2 on a tour of the solar system, but by you guys. So I have a presentation for each of the planets. I went by whoever volunteered first for each of the planets. And if we have time, we're going to throw on one more. So, Hike, we'll throw yours in if we have time because it was pretty good. Thank you for doing a good job. I went by who came in first into the form. You didn't fill out the form. I killed off. So there was a lot, though, of the outer planets. Very little of the inner planets. There was like, so far, I've only seen like maybe like 3 on Mercury, and then like maybe like a handful or 6 on Venus. There's been a bunch on Mars, but there is a lot of Neptune, a lot of Saturn, and Jupiter's got a high number. The form was right here, Eric. Like I said yesterday. Posted with the pictures. Fill that out if you want to volunteer to be a guide. Alright, so we have time to get to see all these and hear them. Let's get into DNA number 4. Similarities and differences between comets. Anybody have any of them? A similarity or a difference? Make me start in a certain spot. Thinking back to our definition, asteroids are smaller, irregular shaped objects that orbit the sun in between usually Mars and Jupiter. Comets are again smaller, irregular shaped objects that orbit the sun but in a more oval orbit and can produce a tail when they get closer to the sun. Jake says they're both rocks that float around in space. Okay, but how about the shape, right? They both are non-spherical objects. I like that, Downey, being a little more specific. Ava, I know they are made of different materials. Good, that's also a thing we can include as in terms of a difference. I'm only looking for one similarity, one difference, but there are several of each. I have a difference. From Hike, a comet has the flaming debris behind it, but an asteroid doesn't. So a comet has a tail, or can form a tail. Asteroids don't, and that is due to what Ava said, difference in materials. Right? So, Azra, they can both come in different shapes and sizes. So, is that a similarity or a difference? Because think now about other objects in the solar system, your planets. Do they all come in different shapes and sizes? They come in different sizes, but do they come in different shapes? Or is Mercury to Neptune pretty much all sphere? Shoot. So let's look at similarity. Oh boy. Can't spell. Let's just go with same and different. You know what? Let's even change that, because we'll use our Venn diagram, right? The whole reason why Venn diagrams exist. Differences and similarities. It might be a little too big, but yeah, I just changed everything up. Couldn't spell similarity. Then I realized same and difference kind of lame when we have Venn diagrams. Two asteroids collided? Well, yeah, these aren't perfect spheres, huh? Alright, so asteroids. Let's see what we've said. They're made of different materials. They're both non-spherical. So we'll say the shape, right? Non-spherical shape. So they both have a smaller non-spherical shape, which means they fail criteria number 2 and 3 of being a planet. Dwarf planets, remember, they just fail number 3. And then asteroids and comets fail 2 and 3. So they only pass number 1, if you want to think of it that way. So they orbit the sun. So they're both non-spherical shapes. Alright? That kind of also addresses they both are rocks that float around in space. Ava and Hike hit on that they have different features and they have different materials. So what are asteroids primarily made out of? Think back a little bit. Remember, I had a picture of the 3 subtypes, and I just mentioned what each type kind of meant. It's a lot of recall for a very minor thing I mentioned. There was M types, C types, and S types. Metals and rocky, yes. So there are a lot of rock and a lot of metal in different asteroids. So this was it. M-type, Lutetia, C-type, Matilde, and then S-type, Ida. 3 different asteroids. M-types are high in metal, right? Like iron and nickel. Even they would be good sources of rare earth metals like even palladium, neodymium, things that we need for electronics, things that are valuable. we may be mining asteroids in the future for those materials. So M-type asteroids would be very valuable. C-types, they don't have metals, but they have carbon, a lot of maybe organic material. And then S-types, they have silicates. Silicate is the shiny stuff in rocks. So they make up a lot of minerals, so lots of rocky material. So metals and rocks. It's pretty much the composition of an asteroid. So I'll go back to our diagram. Made up of mostly rock. And metals. Comets, on the other hand, a little different. We'll come back to the tail in a little bit, but Hike, how do we get the tail? It doesn't have a tail. Comets don't have a tail if they're far away from the sun. So Comet Tempel 1, which we actually sent a probe crashing into to get material, to see what comets are actually made out of, we actually sent a robot crashing into a rocket, into a comet, to see what they're made out of, to confirm what they were made out of. So there is no tail here because it's far away from the sun, but when it gets closer to the sun, many comets produce a tail. Not like this, but usually a tail. The sun burns up the ice and it evaporates. So that's the big thing I want to get at, is comets made up of rock, but also a lot of water ice. And I say water ice because nitrogen, carbon dioxide, they can all be ice at these temperatures. The freezing point out in space is much lower than a lot of these compounds. So we got to differentiate between water ice, carbon dioxide ice, nitrogen ice, right? Azra. So asteroids made up mostly rock and metals. Comets are made up of rock, but also a lot of water ice. This will produce a tail near the sun. So it'll make a tail. Let me get myself out of the way. It'll make a tail close to the sun. All right, and again, that process is going to be important for you to know is the ice basically explodes. It's called sublimation. You go from a solid state directly passing liquid phase to gas. And so it's explosive because gas expands real rapidly. When the gases inside the comet expand and cause an explosion, you're going to have bits of rock fly off a comet. When that happens, those bits of rock are left behind and the comet keeps moving in its orbit. Well, what happens to those little bits of rock? Those little bits of rock catch sunlight and become really, really reflective. And that's what you see as this, the white part. So the white part in this picture are little pieces, tiny grains, maybe palm-sized rocks, all scattered in its orbit. So this would be the path of its orbit, all scattered in its orbit and is now catching sunlight as it gets closer to the sun. So the comet is being shredded because the ice is, if you want to think of it as burning up, the ice is exploding off the comet. Asteroids? It's not an asteroid. Asteroids, not as much ice, so they don't explode when they get closer to the sun. They can break up, but they're not going to produce a tail. All right. I'll go here. Mind is blown from Jake. All right. So we have in similarity non-spherical shape, and then we have differences, no tail or a tail, based on what they're made out of. I think there's one more difference between the two of them. So spherical shape, non-spherical shape, that's pretty much the biggest similarity you can find. But there's two differences. The differences in the tails, but then also location. Where do you find asteroids? Where do you find comets? Location and maybe orbit too. Nobody knows? I mean, I was saving this for Tour of the Solar System, so if I zoom out a little bit. Vesta, Psyche, Eros, Ceres. To some extent, Bennu is kind of went inside the inner solar system. Most of the asteroids are located between what two planets? What two planets are most of the asteroids in between? Where would you find an asteroid? If I asked you, hey, go find me an asteroid in the solar system, where would your best chances of finding one be? What area? Jupiter and Mars. That is the main asteroid belt. So, go back here. Location. Pretty much between Mars and Jupiter. Those of you that did Mars, Phobos and Deimos, don't they kind of look like asteroids? Don't they look like non-spherical objects? Isn't Mars right on the border of the asteroid belt? Good, Downey. Or near Neptune. Those are different, but very similar. We call those trans-Neptunian objects, TNOs. Or we also call them, after where they're located, KBOs, Kuiper Belt objects. Because these objects are in the Kuiper Belt. So beyond Neptune's the Kuiper Belt. I haven't gotten into that in depth yet. I wanted to really focus on these. Okay. Location of a comet is a little different. They can be varying, but they come from way beyond Neptune. Way beyond Neptune. In what astronomers have called the Oort cloud. OORT. So asteroids are usually beyond, are in between Mars and Jupiter. Comets are way beyond Neptune. Their orbits are more circular. And then for a comet, more oval. They're more extremely elliptical. Okay? So orbit, more circular for an asteroid, and then orbit for a comet is more oval shape. They're both non-spherical objects. However, one is made of one material, and the other one has another material. Difference being the amount of ice in them, right? Their composition changes because of where they're located. One's in between Mars and Jupiter, closer to the denser materials in which our planets formed from. And the others are in the outer solar system, where there's a lot less of those minerals to form. Still a lot, though. Orbits of an asteroid are more circular because they're closer to the sun's gravitational pull. Orbits of most comets that aren't going to go into the sun are circular, but the comets that we see are very, very oval because they're so far away, they have to get into the inner solar system. Yeah, we're going to hear about the Neptune diamond rain. We're going to hear about Phobos maybe forming rings in 50 million years. So we're going to start talking about the planets. Let's transition to our tour. All right. Got questions on the DNA, let me know, but this is similarities and differences. I asked for just one to help get you started, but I would also include the other differences, just so you know. All right. Hi, Tina. All right. So, tour the solar system. Let's do that and that. All right. Our first planet from the sun is Mercury, and our first guide on our tour is going to come from Kelsey Bowden, who did Mercury. So on our first stop, we'll let Miss Bowden talk. Maybe I should refresh it.
Alright, for the tour of the solar systems, I chose the planet Mercury. Fine. So this is just a little intro. Mercury is the closest planet to the sun and the smallest in our solar system. It is named after Mercury, the Roman god of travels and the messenger of the gods. Mercury looks similar to the moon, as it is lightish gray with craters, but is far different from the celestial body. There have been 3 missions to Mercury, those being Mariner.
You might want to turn your volume up. There we go. Well, actually, let me readjust that.
10, which was sent out by
There we go.
So this is just a little intro. Mercury is the closest planet to the sun and the smallest in our solar system. It is named after Mercury, the Roman god of travels and the messenger of the gods. Mercury looks similar to the moon, as it is lightish gray with craters, but is far different from the celestial body. There have been 3 missions to Mercury, those being Mariner 10, which was sent out in 1973 as a flyby mission of Venus and Mercury. NASA was the one who sent this out. Messenger, which was a NASA orbiter, which was deployed to get a look at Mercury only in 2004, and Bepi Colombo, an ESA JAXA orbiter sent out to also observe Mercury. The surface conditions, like stated previously, there are similarities to the moon, though Mercury.
Just so you know, because a lot of you brought them up, ESA is the European Space Agency. JAXA is the Japanese Space Agency.
ESA sent out to, like stated previously, there are similarities to the moon, there are still differences. Mercury is riddled with craters. There are also large cliffs called lobate scrapes, and their presence indicates that over time, Mercury's crust shrank and contracted on itself. Near the northern part of the planet, there are flattened plains along with what may be ice. Volcanism also seems to be present with ridges carved out by lava and also a volcano on the surface. Here are the more.
That's crazy that you can have ice on Mercury so close to the sun.
Flores Basin, which is 1,300 kilometers in diameter and one of the biggest impact basins in the solar system and the biggest on Mercury. On the ridge of the Chloris Basin, there also appears to be a young volcano forming, further pointing to volcanism on Mercury. Obviously, it's a volcano. There are hollows in the crater of. Ooh, this was always hard for me to say. Tigergen, I think? A pit in the center may be a volcanic vent, which also helps the argument of volcanism if the volcano doesn't, because it may be a volcano vent that is creating the hollows. The interior of the planet, Mercury consists of a crust, a mantle, outer core, and inner core. First, the crust of Mercury, which is what we see, is actually very thin and brittle. Then the mantle, about 400 miles thick, and that doesn't have a lot of notes with it, along with the crust, because this is the core. The core is what really makes Mercury. Then the core is partly melted, which is where the outer core appears, and is mainly iron. The inner core is actually solid and a mix of iron and other metallic substances. The core takes out 80% of the planet's mass together and is the thickest part of the planet. That's why the crust and the mantle doesn't really have a lot on it, from what I could find. The atmosphere, the temperature, and the weather. Mercury has a very unstable atmosphere and is constantly being replenished. Typically, the atmosphere is about 95% carbon dioxide, nitrogen and oxygen at 2.7%, and argon gas at 1.7%. Because of the instability in the atmosphere, this planet doesn't really see a lot of weather, as you need a stable atmosphere to really get those clouds and precipitation we see here on Earth. To make up for the lack of weather, Mercury being so close to the sun has insane temperatures. In the day, it can reach up to 801 Fahrenheit, which is hot enough to melt lead, and dip to negative 279 Fahrenheit at night.
So it has no greenhouse effect because there is no thick atmosphere. So in the shade, it's incredibly cold, and in the sunlight, it's incredibly hot.
Since the mass and the surface gravity, Mercury is only 58 million kilometers from the sun, less than half of Earth's distance, which is 150 kilometers away. This makes Mercury the closest to the sun, as I've been talking about. Mercury also has a mass of, bear with me, 3.3011 times 10 to the 23rd power kilograms, which again is much lighter than Earth and may help its speedy orbit as well. For surface gravity, Mercury's gravity is 3.7 acceleration. The rotation and revolution period. A day on Mercury is 59 days compared to Earth's rotation of 24 hours. So if you were to put in hours, Mercury's day would be 1,416 hours per day. For revolution around the sun, Mercury takes only 88 days to go fully around the sun and has the quickest orbit out of every planet in the solar system, probably because of its proximity to the sun and small mass. The moons and rings. Mercury has neither moons or rings because of its proximity to the sun, and then the sun having such an intense gravitational force. Because of this, any moon or ring system Mercury may have had in the past or has yet to have would go crashing into the sun basically and be destroyed because its pull is just so strong compared to Mercury, who really can't keep anything in its orbit because it's competing with a star so much bigger than it. However, although there may have never had a moon, it is possible that it could have had a ring system in the past, but obviously now it does not. As no planet in the inner solar system, no one outside the asteroid belt, which is where Jupiter, Saturn, they come into play, has rings. And here are just my sources. I try to stick it to like .edu, .org, and
So she got kind of cut off by Screencastify, but an excellent presentation on Mercury. All right. Next planet out from the sun, in between Earth and Mercury, is Venus. And so we had Kim Rodriguez submit first for Venus to be a guide on that planet.
Venus. The average distance between the Sun and Venus is 67,237,910 miles. The rotational time is 243 Earth days, and the average revolution period is 224.7 days, which is about 62% of an Earth year. Venus may have once had a moon-like Earth caused by a collision between the planet and a large rock. A similar collision then happened again, getting rid of the moon. Venus has no rings due to its mass. If something has a big mass, it has a stronger gravitational pull, causing more things to be pulled toward it to form a ring. The surface gravity of Venus is 0.91 and the mass is 0.82. This is in comparison to Earth. with an axis tilt of fewer than 3 degrees and an orbit more circular than Earth, the amount of sunlight received can cause weather or seasonal changes. The weather on Venus continues to remain about the same, a blanket of sulfuric acid clouds with a surface temperature of 800 degrees Fahrenheit. Even at night, temperature doesn't change because the atmosphere acts as a greenhouse, keeping the temperature pretty even throughout. The weather may seem boring, however, there are some interesting parts about Venus. For example, its atmosphere pressure is 90 times that of Earth's, and the Hadley cell pattern on Earth is the opposite of it on Venus. Venus has many cool features on its surface, such as its 1.5 thousand major volcanoes, with 67% being 20 kilometers wide, and some of its continents being similar to the size of Earth's. Aphrodite Terrace, one of Venus's biggest continents, is about the same size as South America. Another large continent called Isha Terra may have made from thin lava flowing over old crust. The interior of the continent is the Lakshmi Planum. Despite having craters and canyons, along with volcanoes, mountains, and other elevated features, Venus is mainly flat. The elevation differences are only about 2 to 3 kilometers. Some of the main features include volcanoes, mountains, canyons, gray shaded rocks, dust, craters, plateaus, and corona, which is a circular trench. Venus, like Earth, has a crust, rocky mantle, and molten core. The main difference is that Venus's core is more liquid. Some missions. Mariner 1, which is from America, on July 22nd in 1962 it was launched. It was a Venus flyby attempt with launch failure. Venera 4, which was Russian, was launched on June 12, 1962. It took measurements about composition and temperature of Venus. Venera 8, which was Russian as well, was launched on March 27, 1972. It was a Venus probe that confirmed previous data about temperature and air pressure and produced new data about surface based on rock deposit and took measurements of clouds, as well as showed signs that it was suitable for photography. Atlas Centauri, which is American, was launched on May 20th, 1978. It was an orbiter sent to learn about cloud distribution, topography, infrared release, emittance of UV rays, atmosphere composition, temperatures, solar wind, magnetic field, gravity field, and eddy gamma ray rupture events. And one that happened this year from America is the Solar Orbiter. It was launched on February and around 9:10, used to make measurements of the heliosphere and view Sun from a distance. Also did 5 flybys, one of which included Venus. These are my...
Oops. And believe it or not, sending something into the inner solar system probably harder than doing it into the outer solar system because you gotta slow down. Otherwise, you end up in the sun. So these probes, like she said, do a lot of flybys to slow down, to use gravity of other planets to brake. Whereas in the outer solar system, sending Voyager, we use the large gas giants to slingshot out of the solar system. So moving on into the further part, past Earth, into the outer part of the inner solar system, we have Mars. And so we have a two-parter from Mr. Downey. I may have to kind of move you along a little quicker.
So, the planet that I had picked to tell you about is Mars. The upcoming missions to Mars are the Mars 2020 Perseverance rover. Its launch time is in 2020. The Mars Sample Return is the next one, which has a launch window of July 2026 to September 2026. The third one is ExoMars rover, which has a launch time of 2020. The missions previous is the InSight Discovery mission, launched on May 5th, 2018. The second one is ExoMars 2016 mission, launched March 14th, 2016. The third one is MAVEN that was launched on November 18th, 2013. The fourth one is the Mars Reconnaissance Orbiter.
And the Vikings in the 70s, they were the first kind of landers that we put on Mars proper, start studying the surface of Mars. I don't think you get into it, Downey, but the findings there, it had an experiment to conduct if there was microbial life on the surface. The findings came back that it was positive. But then scientists went back and they figured that there was a chemical reaction there that would mimic something of an organic nature. It would mimic a bacteria. Going back now to some of these other missions, we've found out that there is methane being produced on Mars and that there is water underneath the surface of Mars, and methane only really exists through biological activity. It's very rare geologically when we think Mars is kind of geologically dead. So the possibility that Viking may have actually already found something of interest in the 70s is still a possibility. So I'm just going to move you ahead, Logan.
Is the Mars Carrier 6. 4th, 2000, November 3rd, 19 mission was launched Pacific landmarks. The surface conditions on Mars is the surface is very uneven and rocky. The surface also contains volcanoes and canyons and red dust that covers the surface of Mars. The specific landmarks on Mars is they have the largest canyon in the solar system, and it is called the Valles Marineris. It also holds the largest volcano in the solar system called Olympus Mons. Olympus Mons has a diameter of 624 kilometers and is 25 kilometers high. The largest volcano on Earth is 10 kilometers high and 120 kilometers long. Olympus Mons is 100 times bigger than the largest volcano on Earth.
And why? Because Mars has smaller size and less gravity that he's going to get into. So, it can build up higher.
Valles Marineris is as long as 3,000 kilometers and is as deep as 8 kilometers. A canyon on Earth named the Grand Canyon is as long as 800 kilometers long and is as deep as 1.8 kilometers. Valles Marineris, as you can see, is a lot larger than the Grand Canyon on Earth. The interior of Mars. Inside of Mars, there is a dense core made out of iron, nickel, and sulfur. Above that, there is a rocky mantle. Above the rocky mantle is a crust made of calcium, aluminum, potassium, iron, and magnesium. Atmosphere, weather, and temperature on Mars. The air is very thin on Mars. As a result, the temperatures can go down to negative 80 degrees Fahrenheit. In the wintertime, the temps can decrease to negative 195 degrees Fahrenheit. Clouds form on Mars with also strong winds that kick up the red dust from the surface of Mars. The red dust don't settle usually for months, and they don't settle on the surface for months. The distance from the Sun to Mars compared to Earth. Distance to the Sun from Mars is 227 million kilometers, and the distance from the Sun from the Earth is 150 million kilometers. The mass and surface gravity of Mars compared to Earth. The mass of Mars is 6.4 times 10 to the 23rd power kilograms, and the mass of the Earth is 5.972 times 10 to the 24th kilogram. The surface gravity of Mars is 3.71 mass per second squared, and the surface gravity of the Earth is 9.81 mass per second squared.
So the bigger that meters per second squared, the more gravity that planet has. Quick part 2.
The rotational period and revolutional period of Mars compared to Earth. The rotational period for Mars is 1 Earth day and 37 minutes, while the Earth's is one Earth day, which is 24 hours. The revolutional period for Mars is 686.971 Earth days to revolve around the Sun, which is equal to 1.88 Earth years. And Earth's revolutional period is 365.25 Earth days.
I'd ever do it 5 times.
Moons around Mars. In Mars's orbit, it has 2 moons called Phobos and Deimos. The largest one out of the 2 is Phobos, which Phobos' orbit is much closer to the surface of Mars. The diameter of Phobos is 22 kilometers. It rotates around Mars 3 times in one Earth day. Eventually, Phobos will crash into Mars in about 20 to 50 million years from now. Mars' gravitational force will pull Phobos closer, and Phobos will crash into Mars. The smallest out of the two is obviously Deimos. Deimos has a diameter of 12 kilometers, and Deimos's orbit is farther away from Mars. In its farther from Mars in its orbit, and it takes Deimos about 30 hours to create one revolution around Mars. Deimos and Phobos are both not spherical. This is because studies show that Deimos and Phobos were likely to be asteroids before becoming moons to Mars. Unlike Phobos, Deimos will likely move away from Mars. Ring system around Mars. On Mars, currently there have been no ring systems that have formed, but in 10 to 100 million years, Phobos could crash into Mars and create debris to fly back into the solar system. This will create a ring system. A million years later, the ring system will go back to the surface of Mars. These are my sources, and thank you for listening.
Ask me what? Oh, yeah, put it in the form. Good job, Downey. Now, beyond Mars, we've already talked about the asteroid belt being between Mars and Jupiter. So, Mr. Fretz put his in first. We'll take a listen.
Jupiter by Cody Fretz. Missions to Jupiter. Galileo Orbiter. NASA's mission to Jupiter, 1989. This mission was done to investigate the circulation and dynamics of the Jovian atmosphere. Tested the upper Jovian atmosphere. It characterized the morphology, geology, and physical state of the Galilean satellites. It also investigated the surface minerals on the Galilean satellites. It determined the
Leave 'em alone.
gravitational and magnetic fields of Galilean satellites. It also studied the atmospheres, ionospheres, and extended gas clouds of the Galilean satellites. It also studied the interaction of the Jovian magnetosphere with the Galilean satellites, characterized by the vector magnetic field and the energy spectral composition and angular distribution of energetic particles in plasma to distance. Surface conditions of Jupiter. Jupiter is made up of almost entirely of hydrogen and helium, with some other trace gases. There's no firm substance, a surface on Jupiter, so if you try to stand on the planet, you'd sink down and be crushed by intense pressure.
So this is our first gas giant. This is the first of the outer solar system, and a lot of you hit on this, that you will just sink down and be crushed by pressure. So surface conditions, surface features, landmarks, they kind of merge together when you're starting to talk about the outer solar system. But there's more information in terms of moons and rings when you get to the outer solar system. So each planet has its own things to research and find. And kind of push Cody along.
The planet. Specific landmarks or features. The most extraordinary feature of Jupiter is the Great Red Spot, a giant hurricane-like storm that lasted more than 300 years. At its widest, it's about 10% helium. Atmosphere, temperature, and weather. The atmosphere is made up of hydrogen, which accounts for 90% of it. The other 10% is made up of helium, a small fraction of the atmosphere is made up of compounds such as ammonia, sulfur, and water vapor. Average temperature on Jupiter is minus 234 degrees Fahrenheit. The weather can be extreme on Jupiter, that it can be seen from space. The planet experiences mass and surface gravity. The mass of Jupiter is 1.8982 times 10 to the 27th power kilogram. Surface gravity of Jupiter is 24.79 m/s to the second power. Rotational period per day. Jupiter's day varies from 9 hours and 56 minutes around the poles to 9 hours and 50 minutes close to the equator. Period of revolution. A whole moon moons. Most of Jupiter's moons are The most well-known of Jupiter's moons are Io, Euphra, and Callisto. Jupiter also has the biggest moon in our solar system, Ganymede. Jupiter's ring system. Jupiter's rings are formed from dust particles hurled by the micrometeor and must constantly be replenished with new dust from moon.
Overall, he did a good job. Next planet out, rings, and Saturn. This is from Chloe, Korea.
Saturn.
And again, I
Missions to the
may
planet.
push
One
people
mission to
along
Saturn
so
was
we can
the
fit them
Cassini
all in.
Orbiter's mission. It consisted of delivering a probe to Titan, Saturn's largest satellite, and then remaining in orbit around Saturn to study the planet and its rings and satellites. This happened in 1997. The next mission to investigate Saturn was called Pioneer 11. It was to investigate the outer solar system and look at Saturn's main rings. They used Jupiter's gravitational field to alter its trajectory radically, and then it passed close to Saturn and followed an escape trajectory from the solar system. This was in 1973. Planet. Because it is a gas planet, it doesn't have a true surface, and most gases are deeper in the planet. It is made up of 94% hydrogen and 6% helium. Hydrogen and helium are what most stars are made out of. There is a molten rocky core about the size of Earth deep within Saturn. Saturn's surface can get up to about negative 300 degrees Fahrenheit. Features. Saturn is the sixth planet from the Sun, making it very cold and windy. It has the second largest moon in the solar system. That is called Titan. Saturn is the second largest planet in the solar system, and because of this, Saturn is one of the few planets that can be seen with the naked eye. Saturn gives off more energy than it receives from the Sun. This is because the gravitational compression mixed with the friction from helium causes this to happen. Planet. Saturn has 3 layers. The innermost core is very rocky. The core is encased in a layer of liquid metallic hydrogen. The outermost layer is made up of molecular hydrogen.
You guys heard that?
Saturn produces about 2.5
That was a reminder
more
for a meeting.
radiation than it receives from the Sun. There is a molten rocky core about the size of Earth deep within Saturn. Even though this is in Saturn, it is still the least dense planet in the solar system. Temperature and weather. The average temperature on Saturn's surface is about negative 300 degrees Fahrenheit. The reason why this planet is so cold is because it's so far from the Sun. The planet's surface is very cold. The interior is very 7 million miles from the Sun, or 1 billion.
Well, I have the audio bumped up because people's voices are
488,128
low.
kilometers. Because Saturn is a giant gas planet, there is no actual solid surface. Saturn's surface gravity is 10.44 meters per second to the second power, and the rhythm of natural radio signals from the planet. The results give 10 hours, 45 minutes, and 45 seconds as the length of time it takes Saturn to complete each rotation. This is very fast for a planet to rotate. It goes this fast because of the oblate, which means to flatten out the poles. It likely has more in its orbit. Saturn even has the second largest moon in the solar system. It is Titan. Jupiter has the largest moon in the solar system. In October of 2020, 20 new moons were found. And of those 20, 17 of them were red moons, which means they orbit in the opposite direction that Saturn rotates.
Probably captured asteroids.
Saturn's ring system. Saturn's ring system are thought to be pieces of comets and asteroids that broke up before reaching the planet. Saturn's ring system extends 282,000 kilometers from the planet. The ring particles are mostly tiny, dust-sized icy grains to chunks as big as a house. A few particles are as large as a mountain. The rings would look white if you look at them from the cloud tops of Saturn.
And if you're a Destiny fan, there's a massive ship in the rings.
Sites.
Good job, Chloe. Moving on past Saturn, planet on its side. Won't say it. Planet 7. This is from Riley Sullivan.
Alright, Mr. G. This is my touring solar system. So, is the only probe that has ever traveled to Uranus. It was launched in August 20, 1977, and it is still in space today. That is a picture of the Voyager 2. Surface conditions. Uranus is basically a giant snowball. It's a gas giant that's entirely covered in ice. Very cool. A picture. It's an ice giant, like I said before. And it has big
I
icy
had to
hills
put a
and
correction here
mountains.
for him in classroom. It doesn't have hills and
Very
it doesn't
thick
have oceans.
atmosphere, and that's a cool picture I found.
I think he's
There's a
talking
picture
about one of
that
the
could.
moons.
It has a methane interior that's completely frozen in ice. And that's a picture of it there. Of the whole 1.84 or 1.841 billion miles away from the sun, which makes sense why it's pretty cold. From the sun times 10 to the 25th power, or in standard form. I did that math. I don't want to read that number, but it's a big number. Anyway, it's pretty big, and it has a surface gravity of 8.87 meters per second squared.
Good job using standard form.
89% more the force of Earth's gravity, and there's a picture there that it's like there's a bunch of Earths, and it weighs the amount. The rotational period of a day is
Again, these gas giants have very
17 hours
fast
and 4
rotation times,
minutes,
very fast days.
which is shorter.
More
than
mass means more momentum, which means they can spin
and there's
more.
a picture. That's sort of
faster.
what we've
Let's
been
go.
doing in 84 Earth years to do one full rotation around the sun. It would take 30,660 Earth days for one full year. He has Umbriel, Miranda, Titiana, Oberon, Puck, Cressidia, Desdemona, Cordelia, Prospero, Perditia, Setebos,
He does a good
Stefano,
job with the pronunciations, but
Herculo, Ophelia, Belinda,
don't have
Bianca,
time.
Mark is a picture of Umbriel that I found. And its ring system, it has 13 faint rings. The inner rings are narrow and dark, and the outer rings are brightly colored and easier to see. Click on all my sources. I've shared the slide with you if you want to check my sources out. And yeah, that is the presentation. Hope you liked it.
Thanks, Riley. Past Uranus, or Uranus, or Uranus, whatever you want to say. Neptune, last of the major planets. Pluto, we discussed earlier in the week, not a planet. And then outside that is the Kuiper Belt. So Neptune itself, we probably only have time for the first person to enter, which was Ella, to be the last guide. But Hike, I did have yours up. Just probably won't have time to fit them in. And Rainy, you were supposed to use the form to submit if you want to be a guide. Yes. I'm sorry.
Hi, and welcome to my project. This is Trip to Neptune, the farthest planet from the Sun, aside from the possible Planet X, of course, by me. Okay, first is the surface conditions. Neptune is a giant ice planet, and it's made up of water, methane, and ammonia. The landmarks or features. There's a storm on Neptune similar to the one on Jupiter that is called the Great Dark Spot. Neptune appears to be blue. There are a lot of storms that you can easily spot on Neptune. Neptune's atmosphere and weather. Neptune is made up of hydrogen, helium, and methane. Well, the atmosphere is. The clouds in storm systems revolve around the planet. There are wind speeds up to 700 miles per hour. There are also clouds of frozen methane, and there's often storms and aggressive winds. This is all about it. The distance from the sun is 4.5 billion kilometers. The mass is 1.024 times 10 to the 26th power kilograms. The gravity is 11.15 meters per second squared. One day is usually about 16 hours. And
Again, fast rotation time, high gravity, because of the large mass.
Facts covered in. There's a rocky core about the size of Earth, and it's surrounded by icy, hot, dense fluids such as water, methane, and ammonia. More of 80% of Neptune is made up of these fluids. On this journey, they took the first close-up pictures of Neptune, and it took 4 hours and 6 minutes for the signals from the 8 major moons. The first moon was discovered in 1846, and the most recent moon was discovered in 2013.
Again, a lot of captured asteroids or
There are
Kuiper Belt
5
objects here
rings.
in this case.
They were once things when they were, if you want to. And yeah, thank you for.
Ciao, Bella. Hike also had a lot of good information on discovery and background.
So, and Adams began using math to find the location of the
So I'll highlight this slide,
undiscovered
Hike.
planet. Both of their predictions were extremely close to Neptune's actual location. The third person credited with the discovery of Neptune, Galilei, was the first one to see Neptune through a telescope. However, Neptune could have been discovered as early as 1612 by the famous astronomer Galileo Galilei, as he recorded Neptune as a faint star. If he observed Neptune for longer than he had, he would have noticed that its motion resembled a planet. As of April 2020, there has only been one mission to Neptune. It was an unmanned spacecraft named Voyager 2. Voyager 2 launched from Earth in 1977 and flew by Neptune in 1989. However, NASA has proposed a new mission to visit one of Neptune's moons, Triton, around 2038. Neptune is named after the Roman god of the sea. So, there's not too much information about Neptune just because there's only been one mission to it. Rotation and revolution.
And so I'm going to kind of end our tour there. A lot of information. There's some similarities, there's some differences here and there. I wanted you to be an expert on one of the planets. Because what we're going to do is next week during our DNAs, I'm going to have you look at trends among the planets. Rotation period, revolution, alright, the materials, to get a better idea of what the planets are in our solar system and how it formed and what it's like. But also at the same time next week, you'll be working on a document that will be looking at exoplanets, planets around other stars. Are they similar? Are they different? How do we find exoplanets, and how could we even travel to them in the far future for humanity? That's kind of what I want to go into as the next assignment. The next assignment will be kind of, I want to try to do hands-on. So if you have the materials, you can do it. If not, there's alternative things for you to do. All right. So the next assignment is going to be more of you choose what you want to do, and there's 3 options. Each one ties into exoplanets. Okay? But tomorrow, we do have one last day. You do have school tomorrow. There's things you have to take care of, and if you're all set, then you're good. Tomorrow's a big ACLAB day. I am posting the quiz tomorrow, 10 o'clock. I'm going to go over the DNAs. I'll post it. You take the quiz. You're done if you have nothing else to do. Other classes, you have something missing, get that done. I posted just now the notes from the week. You can say those over, look those over. I'll review tomorrow with you, post the quiz. You take the quiz. You're done with science on Friday. All right? If you did not finish Tour of the Solar System, that was due today. Get that done, turn it in. A bunch of you didn't share videos with me because you shared or got the link a different way. I made a comment. Make sure you check those as well. I need to see them if I can give you a grade. Okay? What are the letters for the self-rating? EPIM. Exemplary, proficient, improving, and then emerging with the M. Are we having a stream? I'm posting a stream at 10 o'clock. See who comes up or shows up, who wants to watch. I will go over again the 4 DNAs as a review, and then you guys can take the quiz. Quiz will be posted around 10:30. Review at 10, quiz at 10:30. End the stream early. All right. So notes are in here. You can take a look tonight. Be ready for a review tomorrow. And then ace the DNAC. Okay. Any other questions, comments, concerns? Give you a second because the stream lags. No? Well, if you have your concerns as you go through your day, you can let me know through email and remind, like a lot of you do. And I'll get back to you as soon as I can. Have a good Thursday. Bye, Ava. Bye, Jake. Bye, Ryan. Bye, Logan. Bye, Azra. Yeah, and you can maybe check in with press conference today. Channel 10, Channel 6. Go to turnto10.com, abc6.com. There'll be a stream with Governor Raimondo. I would pay attention to it. Yeah, I know. Well, we'll see. She has to announce it. That was a leak. We'll see what happens. Miss Tyke. Bye, Hike.